Hey guys, lesson 19.2 is continuing our work with systems of equations. Today we're really going to focus on writing the system from the word problem and then solving using either a graph or number sense. So the first thing I want to point out is that you have this little starburst here. And what that means is that when you're doing 19.2 homework, you should be looking at this example to help you. Okay, so here we go. A farmer raises chickens and cows. There are 34 animals in all. The farmer counts 110 legs on these animals. How many of each type of animal does the farmer have? Okay, so this is our scenario. What are we looking for? We are looking for the number of chickens and the number of cows. Once you identify what you're looking for, those two things are going to be your variables. So I'm going to let x equal the number of chickens. And I guess I don't really need to write number of because that's there already. So number of chickens. And I'm going to let y represent the number of cows. Okay. We have some information in the problem that is pertinent to solving it. So we are going to write that down. So we know that there are 34 animals. We also know that there are 110 legs. Okay, there's some other pertinent information that is not in the problem, but it's still information that we need to solve. So we know that chickens, under normal circumstances, have 2 legs. And we know that cows, under normal circumstances, have 4 legs. Okay, all of this is going to help us write our system. Okay, so we have 2 restraints, 34 animals, and 110 legs. So each one of these restraints has to be portrayed in an equation. So if I know I have a total of 34 animals, then that means if I add up the number of chickens and I add the number of cows, I should have 34. So we have variables, x that represent the number of chickens and y that represents the number of cows. When I add those together, I should get 34 animals. Our second equation in our system has to deal with the 110 leg restraints. So I know that chickens have 2 legs, so I can take 2 times the number of chickens, which is x, and add 4 legs times the number of cows, which is y, and that should equal 110 legs. Okay, so we could use number sense to solve this. We could go through guess and check. We could try to make a table. All of those are going to take you a while unless you get lucky with your first or second guess. So my suggestion would be to use Desmos. So I am going to be flipping back and forth between the notes page and Desmos. Okay, so here we go. I'm going to pull up Desmos and I'm going to type in my 2 equations. So my first equation was x plus y equals 34. And my second equation in the system was 2x plus 4y equals 110. Right? And we know when we're trying to find a solution to 2 equations, we are looking for the intersection. So I am going to click on that intersection and it gives me the point 1321. Okay, so I'm going to go back to my notes and I know that when I solved the system, I got 1321. Okay, but that doesn't really mean anything in the context of the problem. So we need to go a little bit further and state what the 13 and the 21 means. So the 13 is our x coordinate, which means that that is the number of chickens. 21 is our y coordinate, so that means that we have 21 cows. And you're done. Let's move on to the next one. So you have 14 coins in your pocket that are either quarters or dimes. They total $2.50. How many of each type of coin do you have? What are you being asked to find? You're being asked to find the number of quarters and the number of nickels. Okay, so those two things that you're being asked to find, those are your variables. So we need to make sure that we label our variables. Very important that we always define and label our variables. So let's make X the number of quarters. And let's make Y the number of nickels. Right, now we're going to go through our conditions and our pertinent information, our relevant information. So we know we have 14 coins. We know that we have $2.50. Okay, we know that they're all quarters or nickels, and it's not listed in the problem, but we also know how much money a quarter is and how much money a nickel is. So we know that quarters are 25 cents, and we know that nickels are 5 cents. Okay, and because our constraint is $2.50, we want to make sure that we're writing our costs for quarters and our costs for nickels in terms of dollars. Okay, so that's why I have 0.25 and why I have 0.05. Okay, so we go to write our system, and we have two constraints. We have the 14 coins and we have $2.50. Those two restraints are going to tell us what our two equations are about. So we need one equation that represents 14 coins. So if I take the number of quarters, which we said was X, and I add the number of nickels, which we said was Y, I should have a total of 14 coins. Our second equation has to deal with the $2.50. So I know that each quarter is 25 cents. So I can take 25 cents times the number of quarters, and I can add 5 cents times the number of nickels, and that total should give me $2.50. Okay. All right, I'm going to go back into Desmos and enter these two equations in. Okay, so I have X plus Y equals 14. Oh, not 17, 14. And then I have 0.25 X plus 0.05 Y equals 250. Okay, I'm actually gonna zoom in a little bit on this so that we can see our intersection a little better. All right, so there's our intersection right there. That's what we're looking for. I'm just gonna click on that point, and I can see that that intersection is 9, 5. So I'm gonna go back into my notes, and I know that the ordered pair is 9, 5. But what does that mean in the context of our problem? Well, we know that X represents the number of quarters, so I have 9 quarters. And we know that Y represents the number of nickels, so I have 5 nickels, 9 quarters and 5 nickels. And you are done. Okay, last one on this page and last one for this video. Number 3, at an ice cream parlor, ice cream cones cost $2 and sundaes cost $3.50. On one day, the receipts for 114 cones and sundaes totaled $305. How many cones and sundaes were sold? assume that tax is included in the cost. So what are you being asked to find? You are being asked to find the number of cones and the number of sundaes. So those are both of our variables. So let's define our variables. Let's let x equal the number of cones, and let's let y equal the number of sundaes. Okay. And let's go through and get our pertinent information relevant to our problem. So we know that there are 114 total sundaes, or total altogether, 114 items, let's say that, 114 items. And we know that the total cost was $301.50. And we're also told that cones are $2 and sundaes are $3.50. What are our constraints? So our constraints are the fact that we have 114 items and we have $301.50 in sales. So one of our equations has to deal with the total number of items. The other one has to deal with the total number of money. So I know that x is the number of cones. So if I take x and I add the number of sundaes, which is y, that has to total 114 items altogether. My second equation has to deal with the money. So I know that my ice cream cones cost $2. So I can take 2 times the number of ice cream cones, and I know that my sundaes cost $3.50. So I can take $3.50 times the number of sundaes, which is y, and that has to total $301.50. Right? Let's go back to Desmos to solve this guy. Okay, so my first equation, x plus y equals 114 items, and then we have 2x plus 350 y equals 301.50. Okay, we're gonna have to do some zooming out to find these lines, and there they are. And we're gonna click on that intersection, and we have 65, 49. So I'm gonna go back and write that in the notes. 65, 49. Okay, again, that doesn't mean anything in the context of the problem, so we have to give it context. So since x is the number of ice cream cones, we have 65 cones. And since y is the number of sundaes, we have 49 sundaes. Okay, we are done with this one. I will post another video for the second page of notes. Talk to you.